Seabird 198, one localizer established, descend RF.
One reception localizer, send RF, 21.
Seabird 198, could you give me a wind check, please?
Showing 240.
So basically now we're south of Honolulu, and we're just communicating via CPDLC, so we're physically not talking to anybody. We've been flying now for about 7.5 hours, and we've burnt 64,500 kilos of fuel, and we have roughly 7.5 hours left to go. We've climbed up now to one of a more efficient altitude. We're cruising at 34,000 feet. Very, very light winds. I don't know if you can see this, but the winds right now are 316 degrees at only 6 knots, giving us a ground speed of 489 knots. Our next reporting point will be Bestie, and at that point we'll also send a position report to our company. When we fly internationally, because we have what's called a flight watch system, every 2 hours or less we have to send a position report to the company so that they're aware of our fuel on board, our time over the waypoint, just to see how our timing is going, and we send them the weather and any other criteria that we deem appropriate. Manj and I have been up here about 3 hours now. We came back from our first break, and in about 5 minutes we're going for our second break, and the other 2 pilots come up and take over control of the aircraft. In fact, we're going to call them now. Manj is going to do that with the alerting system. You can see on our radar now, there's a little bit of weather just to our left, but it's slightly below us, and it's very small weather. I can change the scale now. You can see right there, that is 160 nautical miles. If I reduce the scale slightly, that's 80 nautical miles now, and you can see the weather looks a little bit bigger because I've changed the scale. None of it's red. We don't like to see any red. We try to avoid the amber also, or the yellow. Green, bit of a rain shower. Right now we're burning roughly 8,000 kilos per hour.
My name's Louis Parizzelli, and I live in Vancouver, Canada. I work for Air Canada, of course, and I'm in the right seat of a 777-200 right now. I'm a relief pilot for the main crew that are on a crew rest right now, and I'm in the process of doing a position report to the company. The position report has to be done every 2 hours to keep dispatch up to date as to our progress. So on the flight plan, what we do is we have a little system we've invented here where we do triangles at every 2 hours, every waypoint, and every time a report is sent, we just fill in or color in the waypoint. So I'm in the process of doing Beastie, and the way we send this position report is by
Data link.
Thank you very much. Data link, of course. And it's done over here on the screen. What I do is I set the position Beastie, and I give them all the information they want. Beastie, we have the time we were at Beastie and the altitude at 340 over here. I give them the winds, and I can give them the component, which appears on the adjacent screen of a tailwind of 8 knots. So I'll just put in 8 to the component. Intensity, there's no turbulence right now, so the intensity is 0, and it's C for continuous. Also, I'll give them the fuel at our waypoint, which is 67.7. I enter that. I could enter the estimate for the next waypoints. It's not necessary. Some pilots do, some others, some don't. In this case, I'll choose not to. So I'll send that away, and it goes to dispatch at our company. And of course, I filled in the waypoint little triangle. And that's all there is to position waypoints, position reports.
Okay, if you check on my nav display, we've just reached a point we had created on our fix page, which is right here. I can bring it down, selected as point north 06, west 171, and that is our critical point on our flight plan, and it's a point which is calculated by dispatch, and it would be the point at which it's an equal time point between, in this case, Honolulu and Apia. In other words, in a worst case scenario with an engine failure and a depressurization, it's our diversion time to those airports where it'd take the same amount of time to return to Honolulu or continue on to our other ETOPS alternate of Apia. So from this point forward, returning to Honolulu is no longer our shortest ETOPS alternate. Would now continue to Apia. And that is also on our plotting chart. We plot that point just for increased situational awareness as well. You can see it's here. We've continued down from the Hawaiian Islands here. We've just crossed our critical point number 2. And now we're continuing to our ETOPS alternate. And again, this is a worst case scenario alternate for us. Okay, the captain had mentioned earlier, explained a little bit about the electronic flight bag and some of the conveniences that provides to us as aircrew with the reduction of amount of paperwork that we actually have to carry in our flight bags. I'm just going to go into a little bit more detail, explaining some of the features of our electronic flight bag. The airport map was already explained earlier. This is our main menu, and where we can select the different features of the electronic flight bag. There was the performance for calculating the takeoff performance for maximum takeoff weights and V1, V2, and VR speeds, so on and so forth. And then terminal charts, basically the Jeppesen approach plates and charts in general. The other section is documents, and this is our aircraft operating manual, flight ops manual, route briefing notes, training manual, minimum equipment list or MEL, flight op airway text manual. In any case, if there's a system that we need to reference to get some more information or refer to, we can select it on here. And this is our SOP section, actually. And from AOM Volume 2, we can take a look at any individual system in greater detail with a this would be referencing the air with a drop-down menu type of interface, and now we can look at the aircraft system manual, system descriptions. Further to that, route briefing notes. This would provide a reference database for any particular route that we're flying. If we just need some background material that's been collected by the company. Selecting here, it's the menu is by country in this case. South Pacific is what we're operating now. The page that I pulled up is just referencing Australia, and it would just go into some detail on differences that we would need to know for operating in Australia versus Canada. And we can just collapse the menu back to the top. Again, this is a great convenience for the aircrew to have this available to us.
We've just had an ICAS message, fuel low center, seeing we've departed Vancouver. Using the center tanks, we've reached a point where we've depleted nearly all our fuel in the center tank, and we've had this ICAS message, fuel low center. So our procedure at this point is, I can draw up the diagram. Here's the center tank, and there's center tank fuel pumps, and there's indicating 1.1 kilograms of fuel in the center tank. So at this point, our procedure is to turn off the center tank pumps. And this is what I'll do one at a time. I'm turning off the left center tank fuel pump, and you'll see in the diagram that that's been accomplished properly, and I turn off the right center tank fuel pump, and that's taken care of as well, shown on the diagram. So that's our procedure, and the ICAS message has gone away. So now we're operating with our main tank fuel for the rest of the flight.
All right, we've picked up an area of weather ahead on our track. It'd be convective cloud thunderstorm activity, and we've seen some active weather with lightning flashes and so on. So we have requested a clearance to deviate off our track via data link. We've requested up to 70 miles right of track to avoid the entire area. That will hopefully ensure the smoothest possible ride through the weather. And we've gone on to heading select, and now we're just deviating off our flight plan route to hopefully avoid the turbulence associated with that, and do our best to give the passengers a smooth ride. With this weather radar, it is selectable. I guess it takes the raw information, and through the processor, we're able to select what actual altitude the weather returns are occurring. So I'm looking at 36,000 feet right now. We're at 36,000 feet, and we can select lower altitude or any altitude. That's showing right here on my nav display. That's 35,000 feet, 34,000 feet. And as I rotate this knob on the radar control panel, we can change the altitude that the returns are being displayed. Yeah, it's common to see convective cloud, convective buildup in this part, on this section of this route, yeah. All right, so we've navigated around the weather, which was essentially a line of thunderstorms, and we managed just to experience just a little bit of light turbulence going through that. We deviated up to approximately 45 miles off of our track. We were cleared up to 70 miles off track. That's denoted by this dotted white line. That was our clearance up to deviate up to 70 miles off of our flight plan route. Now that we are around the weather, we are just using heading select to navigate back towards the pink line on our nav display, which is our flight plan route. And once we get back close or onto our flight plan route, we'll go back to LNAV, lateral navigation, and let the autopilot take control of the heading of the aircraft again.
Okay. Sir, here we are now. We've been flying exactly 11 hours and 10 minutes in the middle of the South Pacific, cruising at 36,000 feet, flight level 360, and indicating Mach 8.30 as per our clearance. Actually, ETOPS is finished at this point. I'll show you on the chart. This was our airway here, Bravo 580. And if you can see the little brown line, that's the 430-mile arc from the airport of Nadi, and that signifies that ETOPS is officially finished for us, and we're officially within an hour of a suitable airport. Up to this point, we've burned 95,300 kilos of fuel, and we have roughly 5 hours and 20 minutes left in the flight, so it's progressing quite nicely. So our position at the present time is we're a little bit south of the island of Vanuatu, and they filmed a Survivor series there called Survivors Vanuatu, and as you can see on my nav display ND, we're about 80 miles away from the island of Vanuatu, and right now, if we had a problem, that would be probably our main diversion airport. We've already looked at the charts, we've cross-checked the weather, and it's suitable for us. We still keep our radar on. As you can see, there is nothing on the radar screen, but we still keep it on so that we want to avoid any unpleasant surprises. As you can see, it's pitch black outside, and we don't want to fly into any unexpected cumulus-type cloud. Anything you can think of, Manj, to add about how we figure out our position or anything?
Well, I guess we could make the point that when we look at this line on this ND navigational display, yeah, it looks nice, and this is our airplane depicted on it, but really it's just a picture. It doesn't really mean anything unless we have confidence that the information that depicts this line is accurate. So right now our required navigation performance is 4 nautical miles, and our actual navigation performance is within 0.06. So what this is telling us is that we have very accurate information. Now, how is that happening? Well, if we look at our position reference, so I'm looking in the FMC to see, all right, how is this position being depicted? Because if the accuracy wasn't there, being on this line really doesn't mean anything. It's nice to look at, but it would mean that we're actually not in the position that we want to be. It's just a line that's inaccurate. But if we look at the FMC position reference, we can see that it's using a GPS position, and the FMC is practically mirroring the GPS position. Now, global positioning system are the satellites that are in orbit, and we're using up to 3 to triangulate the actual position of the airplane. So it's very accurate, and we can say with certainty that our FMC position is what it's saying, since our GPS is correlated with the FMC position. If we didn't have GPS, then we would want to be in a radio navigation rich environment. In other words, what we call vortex or VORs, and even NDBs can be used to triangulate and update the FMC. What is the FMC really? It's navigation by laser ring gyro. So it's an inertial reference system, and that system will have a bias to drift. Nothing's perfect. We also have the fact that our navigation error can build up by the fact that we're flying over a sphere, and as we go along there are precession errors, even in a laser ring gyro system. So we update that those errors through one of 2 ways, the GPS or the radio nav. Even then, it's an incredible machine, because if we don't have radio nav or if we don't have GPS, we can still go for 18 hours without updating the FMC, the laser ring gyro, and that still provides us with a very good nav accuracy, especially again compared to the old inertial navigation systems that had mechanical gyros and had a lot of air built up in them because they're mechanical. So that's just sort of a black, what's really behind the black box magic. And the fact that when you're looking at these kinds of systems, that you really have to be wary of your raw data proving that that in fact is the line you want to be on. Otherwise, it could be just a false representation, which could be dangerous. Explain this system a little bit. As I had referred to earlier, we can get things, we can send position reports, and we can get all sorts of reports from dispatch that's watching our flight progress along, and he can send us weather reports or notices to airmen. And for example, if we look at one such message, I'm looking at the weather here that's been sent, and we can view it here or print it and retain a copy so that we can refer to it at any time and use that weather with our EFB. We can actually show our the alternates that are around us on our EFB.
So we have a feature here in the EFB, and it's called Chart Clip. This is kind of like the home page. One of the selections here is called Chart Utilities, the bottom right button. When we select that, it gives us three menus. One is Use Airports from FMS, that'll be the ones that's in Manja's side. And then use the chart clip from other FMS, and Nearest Airports. So when I select Nearest Airports, the beauty of that, it gives us airports in distance that are closest to our airplane, pardon me. We can see the closest one right now is Vanuatu. The airport's called Bauer Field. The bearing to the field is 347 degrees, 95 nautical miles, and the runway is 8,530 feet long. If we had to divert to that airport, we could select this. It now comes up with a menu of charts that are available for the airport. We determine from the weather, let's say that we want to land on runway 11. I select the VOR, localizer DME runway 11 approach plate. And now I have the approach plate with which to conduct the approach. And it's right at our fingertips. We don't have to dig it out of manuals. It's very convenient for us. On the North Atlantic is all tracks. And the tracks move north or south depending on the jet stream. And it's decided, and they're plotted twice a day by the various air traffic control systems. Whereas on the South Pacific, it's designated airways. So we're flying from Vancouver all the way to Sydney, Australia. There are basically 5 to 6 major airways, and we're usually on one of those airways. Because of that, we don't require an extra clearance. Our actual clearance on the ground in Vancouver will take us all the way to Australia without having to obtain what's called an oceanic clearance. Whereas when we fly from any point in Canada to anywhere in Europe, before we leave the Canadian coastline, we need a further clearance called an oceanic clearance, which clears us on a specific track, a specific altitude, and a specific speed. And then we have to plot that track and ensure that it agrees with the daily track system. And none of that is required on the South Pacific. Also, because of the South Pacific, because of the tracks, the ADS, which we talked about earlier, and the CPDLC, we hardly ever talk to anybody because our position is automatically transmitted to the various control centers via the ADS. So there's no requirement for us to physically talk to the control center.
The other feature about South Pacific flying is the Intertropical Convergence Zone. Now, that's nothing navigation related. It's more an area that is curious from a weather point of view, and it can actually be quite challenging. We're generally talking about 10 to 15 degrees north and south of the equator. And why it can be challenging is that we're usually used to, in North America, dealing with air mass weather. So large areas of air mass of different quantity of humidity and temperature, which can generate thunderstorms in the summer, for example, around Ontario. And these can be quite large features, and they're easily picked off by the radar, and you can have a strategy of getting around them. We always avoid thunderstorms. It's not our job to pick through a line of thunderstorms. We avoid that line. So radar is not used to pick our way through anything. It's used to avoid them altogether. But in the intertropical convergence zone, the problem is we're not dealing with large air masses that have a lot of moisture. You actually end up with these cumulonimbus clouds, which don't necessarily paint, and when I say paint, have a reflective quality because there's not a lot of moisture, relatively speaking, and yet by the nature of the intertropical convergence zone, these cumulonimbus clouds can reach quite high, right through our stratosphere. And the challenging part is trying to, especially when it's very dark, there's no moon, or for that matter moonlight and daylight right now. So we're really relying on this radar to pick off something that shows us that one of those cumulonimbus clouds could be around us or in our way. And it can be quite challenging because even the smallest dot can be significant on the radar. And the other thing is that they develop very quickly. So you may think that you're going to, this radar will actually show you things that are below you. It'll be hatched. And you may think that, okay, I'm going to overfly it, but it can be so unstable that they'll actually be growing vertically. When you get there, you're actually in them, and that can be very dangerous. So you've really got to make sure that you're not relying on the cloud staying low. It can be very virulent and unstable. And that's certainly one of the challenges of the South Pacific. Anything to add to that, Dominic?
No, I agree totally with everything you said there.
And, you know, that 330 that went from South America,
Air France?
Air France, straight into the intertropical convergence zone, that satellite picture showed extreme instability, and it's not known yet how or why they ended up going through that extreme instability, but they didn't fare well. So it can be very dangerous. Even with amazing technology, that thing called airmanship still applies.
Exactly.
And healthy respect about Mother Nature. Okay, so what we have here is an open diamond, and it's saying 00, which means this traffic is co-altitude, and it's off to the right, 12:30, 1 o'clock, and you can see that I have 160 nautical mile range selected, and the midway is 80, so that'll be 40, and we're looking at between 40 and 80 is just shy of 60 miles. Now that's generated through a traffic collision avoidance system, TCAS, and TCAS is, we can look at things below us or above us if we want to isolate below or above. Usually we have it below and cruise, some use norm. And it's just another way of situational awareness of what's around us. Obviously, it's air traffic control's job to deconflict traffic on the airways, but the traffic collision avoidance system is yet another safeguard against any potential chance of collision. Now, it only works if the other airplanes have transponders as well, and in this airspace that would be the case. You wouldn't find in this form of airspace airplanes without those transponders. And the thing is that we may not visually see these things, and if it gives us a resolution advisory where it wouldn't be an open but a red target, it'll then tell us whether we should climb or descend to deconflict, and we would have to honor that resolution advisory, and we would advise ATC that we are doing that. And we can use other methods of being seen, and that's we can turn our lights on. And we are already using the TCAS, obviously, but our lights makes us visible. And if need be, we could even talk to people on the air-to-air comm and make everybody aware of what we're doing. So everything is relying on as many ways as you can communicate, visually or verbally. All right, here's a situation that's developed that follows with our use of traffic collision avoidance system. That traffic, which the transponder is off, there it is just under 60 miles away, and we got a message, digital message from ATC that came up and said maintain Mach 8.3 or less, which we accepted, and we are in fact doing Mach 8.3. And obviously they don't want us to close in on this traffic because he's co-altitude, and in RMP 10 airspace we're supposed to have a longitudinal separation of 50 nautical miles or more. So this is just a good example of air traffic control doing their job, and we are maintaining our situational awareness of what's going on around us with the use of the tools that we have on board. TCAS, Traffic Collision Avoidance System for short, the acronym is TCAS, is helping us maintain a situational awareness of what air traffic control is doing as well. So it's just a nice example of what we do routinely. I'm going to get rid of that, and it'll notify us if ATC's got something else to say.
So we're going to conduct our approach briefing, and we do that using our terminal charts off the EFB. So I've loaded up two charts. I've loaded up the Marlin 8 arrival, and then from there we'll transition to the ILS on 16 right. So we start off like this, and Manj is going to follow me through on the legs page to make sure this is reflected there. We're doing the RNAV Star in Sydney, Australia. It's 10-2E, effective 20th of November. It's called the Marlin 8 arrival. It says the speed maximum 250 knots below 10,000 feet. Transition level for us today will be flight level 110. It says for runways 16 left and right, track 264 to Prawn, cross Prawn at or above 6,000 feet. And we've inserted that into the FMC as a constraint. track 265 to the SYVOR, and then expect radar vectors to final. And that's exactly what we have in the FMC. And as you can see, we have a discontinuity after the SYVOR because we'll be provided radar vectors for the approach. Transitioning to the ILS runway 16 right in Sydney, chart 11-7, effective 11th of March. The localizer is IKS 1095 and with a track of 155, and we cross-check all this data as we're talking about it. The outer marker interceptor altitude is 1,310 feet, down to an MDA, a decision altitude of 220 feet on the barometric altimeter. Monitor announce approaching minimums and minimums. I'll call landing or go around flaps 20. In the event of a go around, we'll track 155 at a mandatory altitude of 600 feet. Right turn, track of 170. We'll climb to 3,000 feet or as directed by ATC. And we can see that that indeed is in the box, and then the aircraft will do that in LNAV for us. Highest quadrant off of the SYVOR is 2,700 feet. And altimeter setting in Sydney is hectopascals. Under the notes here, it says that the SYDME is required. Mind you, that's for localizer only, but we insert it, and we've inserted it in the right-hand VOR. Charted visibility for this approach is 550 meters or 0.8 of a kilometer. And on landing, we'll be planning to turn off. We're using auto brake 3 and idle reverse, and we'll plan either Alpha 4 or taxiway Lima, and then turning right onto Alpha towards the terminal building to our gate assignment, which we have not received yet. And then once we finish the briefing, I ask for what's called the pre-descent checklist. And Manj will read that to me.
Recall.
Recall is checked.
The notes, there are none. Auto brake, you said 3. Approach briefing, completed. Landing data, we have a VREF of 138. Minimums 220 on the barometric. Pre-descent check complete.
Roger.
Good morning, Brisbane Centre. Star clearance, Marlin 8 arrival, runway 16 right, maintain flight level 370.
Marlin 8 arrival, 16 right, maintain flight level 370, and that's for your information, negative PRM.
Canada 2033.
Did you happen to know what they'd be planning for transition speed descending? We've been restricted to Mach decimal 80 currently.
Canada 2033, I'd like you to maintain minimum speed if you could, thanks. I need you to cross Marlin at time 22 for a landing time of 42.
Okay, Marlin at 22. We'll see if we can do that here, Canada 2033.
Canada 2033, you can expect vectors for delaying action.
Air Canada 2033, okay, thanks. We'll maintain Mach decimal 80.
Canada 2033.
And FedEx 77, make your indicated airspeed now 250 knots, thanks.
Okay, we're indicating 250, FedEx 77.
Okay.
Flight level 300 for flight level 200. Okay. If you'll give me 250 knots in the VNAV descent, please, Manj.
You mean right there?
Yep. Execute. Thank you.
FMC, enable RTA.
Roger. Cancel. Well, it's changed to 18 now, so we've lost 1 minute. I have to lose what, 3 more minutes?
Air Canada 2033, we're been at 250 knots for a while now.
Thank you. If you just keep it 250.
250 knots over there. Plus or minus 3-4 knots.
Canada 2033, resume our navigation now, track direct to Marlin for the Marlin 8 arrival. Canada 2033, descend 10,000 feet, Sydney QNH 1020.
10,000 feet on 1020, Air Canada 2033.
10,000.
Connor Sydney.
Roger, 10,000.
6017, go ahead.
Yeah, just for your information, they were going to load
And just
some
to review,
extra containers
transition is
to go down to
flight level
Melbourne.
110.
They're unable to load those this morning. Your zero fuel weight will be reduced by approximately 1,400 kilos. Are you right for that to reflect in the final load too?
Oh, I'm just looking at this weather. It can't be too bad. This guy's 7,000 feet below us, going through it.
About 10 degrees left for weather for about 5 miles.
We're in idle VNAV path.
Thank you.
And hold. When the airplane goes into hold, it's up to us to add power or subtract power to maintain speed in the vertical path. Something interesting with this airplane, it has automatic engine anti-ice and wing anti-ice. And on older generation airplanes, we probably would have the engine anti-ice on this point, but with the auto, it's saying I'm not detecting any ice, so it's not putting on any engine anti-ice or any wing anti-ice.
24-4, Air Canada 2033, get in. Sydney approach, it's Air Canada 2033, heavy, 17.1 descending 10, 10,000 on 1020, and we have whiskey negative PRM.
Canada 2033, good morning, descend 9,000, runway 16 right, expect independent visual approach. We have about 70 miles to run.
9,000 for 16 right, Air Canada 2033.
9,000 is set.
Roger, 9,000 set.
I missed his remarks there. He said expect what?
Expect 70 miles, he said, to range.
Sydney approach, Hotel 450, good morning, information, whiskey descending 10,000.
You can see that the airplane's getting a little bit fast, trying to maintain the vertical path, and they wanted only 250 knots, so I'm going to use the speed brakes, bring the speed back just a little bit. And when we use the speed brakes, we keep our hand usually on the speed brakes all the time, so as we don't forget to put it back down. There we go, speed's back, and I'm going to retract the speed brakes. Start to see the lights of Sydney now.
Galway 771, turn right, heading 180, intercept 16 right, localizer, report established.
Well, I'm happy, man. I'm taking my weather radar off.
80, report established, command.
17, contact director, 125.3.
125.3, Delta 17, good day.
Galway 771, contact director 126.1.
126.1, Tuesday, 771.
So as we're approaching the transition level, which is 110, we're going to be setting the current altimeter, which is 1020 hectopascals. That's what ATC gave us, but we also cross-check it with an independent source, and the ATIS is also saying 1020. So we'll set it now, and I'll go 1020 hectopascals set twice.
1020 hectopascals, cross-check.
Thank you. And routinely we do what's called the in-range check, either through 10,000 or 30 track miles. So I think we'll do it now, man. The in-range checklist, please.
Landing data. Set.
So with the landing data, we're making sure we have the ILS tuned, we have our approach speed set, our minimum set, and the approach on the standby instruments, and I repeat it and I say reviewed and set.
Altimeters 1020 hectopascals.
1020 hectopascals.
In-range check complete.
Thank you, sir. 10,000 for 9,000.
Roger.
Canada 2033, descend 7,000.
7,000, Air Canada 2033.
Okay, 7,000 is set, and there's no other constraints that would inhibit that, so 7,000 set.
Roger, 7,000 set.
Speed. Till it goes my way. Okay. Let's just go to flight level change at this point. We have thrust now, flight level change speed, 9,000 for 7,000.
Roger.
2033, descend 6,000.
6,000, Air Canada 2033.
6,000 is set.
Roger, 6,000.
As we get closer and closer to the airport, we keep reducing the range. We started off at 640 in cruise and slowly bringing it down so that the picture keeps getting expanded, improving our situational awareness.
6,000 for my 165, jets 38.
7,000 for 6,000.
Roger.
Hold. Speed alt. Leveling 6,000.
2033, turn right, heading 335 to downwind.
3353, Air Canada 2033.
Okay, heading select, coming right, 335.
Roger, and let me know when you want
Go ahead and extend the center line, please, from the final. Oh, that's good too.
155 degrees, course 2.
And execute, please. Thank you. So what Manj has done now is put us kind of into an approach phase where he's extended the center line of the approach, and that gets rid of all the extraneous data. I start slowing a little bit, Manj, to 220 knots.
Sounds good. Air Canada 2033, we're reducing to 220 knots.
Air Canada 2033, roger, contact director 1253.
125 Air Canada 2033.
It is 450, descend to 3000.
There's the airport just on our left-hand side. We're being vectored downwind left-hand.
Sydney Director, Air Canada 2033, heading level 6000, Boeing 777.
Air Canada 2033, good morning, descend to 4000 feet, runway 16 right, localizer check 1095.
4,000 feet, check 16 right, Air Canada 2033.
Okay, 16 right's the approach we have loaded. 4,000 is set. Thrust, flight level change, speed.
Roger, 4,000.
5050, it's at 450.
Hold. 5,000 for 4,000.
Roger. 4,200, a little high, but working out well.
And those speeds are good for final at that weight. We're below our max landing weight, just barely.
Yep.
Yeah, 450, cleared ILS approach 16 right.
Approach 16 right, at 450.
So pretty soon, once he turns us base, we'll start slowing down by taking flaps 1 and then flaps 5.
Canada 2033, descend to 3000 feet and turn left heading 26 right, bye-bye.
Left 260 down to 3,000, Air Canada 2033.
And 3,000, 4,000 for 3,000.
Roger, 3,000 set. 1 is selected.
And as we slow, I select the flaps 1 speed, as you can see over the 1 indicator. Hold. And we want to be at 200 knots or less within roughly 10 miles of the airport below 3,000 feet. And we have IKS now. Well, it identified for a second, then it disappeared.
That's the guy right
Traffic on final, we have contact. Flaps 5, please, Manj.
5 selected.
Air Canada 2033, turn left heading 185 for pilot intercept of the localizer, cleared ILS 16 right approach.
25 degrees, cleared the LS 16 right approach, Air Canada 2033.
So he's cleared us for the approach. I've armed approach. I can see localizer and glide slope are armed. And he's given us an intercept heading, and we're slowing to the flaps 5 speed.
And 3,000 is our missed approach as well.
Thank you, Manj.
India 450, 5 miles behind a 777 on about a half mile final left for the south, 120 decimal 5.
120 decimal 5, it's at 450, boy.
There we can see we are going to have a nice headwind on final.
6 miles or so separation.
Air Canada 033, descend to 2,200, still cleared the ILS approach, and QNH now 1021.
2,200 still cleared the LS 16 right, and 1021 hectopascals, Air Canada 2033.
2,200 set, and I'll bring it slowly down in vertical speed.
1021.
1021 hectopascals is set.
Roger and Roger, 2,200 is set.
Thank you, sir.
Runway's coming in nicely.
I
Visual.
see the runway in sight. Thank you. Flaps 20, please, Manj. There's Loke.
20 selected.
Director, good morning, our China 173, 6,000.
Hey, China 173, good morning, descend to 3,000 feet, cleared ILS approach 16 right.
On the 3,000, clear eyes, 16 right.
First glide slope, missed approach is 3,000 feet, and that is set.
However, if you could maintain not below 180 knots until 6 miles.
Until 180 knots until 6 miles, our China 173.
Canada 2033, contact the tower, 1205.
1205, Air Canada 2033.
Okay, sir, approaching the marker. Gear down landing checklist, please.
Okay, cabin. Alerted.
And gear down landing checklist.
Down. Still. Power to Air Canada 2033, heavy. LS 161.
Again, 2033 tower, good morning.
Tops to go.
Roger, sir. Beautiful view of downtown Sydney on the left.
Sydney tower, good morning. Jetstar 762 is ready.
Land 3.
Star 762.
Rollout and flare are armed.
450, take the next right, Lima, no delay vacating. Lima, no delay, 450.
Okay,
John, make you after the next one.
VRF 138.
VRF 138, target 143. Landing clearance to go.
Clearance to go, landing checklist complete now.
Thank you, sir. Autopilot's coming off. Flight director.
Roger. Just about clearing there.
Okay. And we will be clearing to the right, if I didn't say that.
That is right. Should be getting in shortly for clearance.
Air Canada 2033, wind 220 degrees, 6 knots, runway 16 right, clear to land.
Clear to land, 16 right, Air Canada 2033.
So a little bit of wind from the right, and at about 30 feet, we'll be slowly closing the throttles and pitching up about 1 degree for our landing attitude.
Approaching minimums.
Roger.
Minimums.
Runway inside.
Landing.
$100. 50. 40. 30. 20.
Oracle, Macau, Charlotte 73. Publish, alright, so that's right.
Speed brakes up.
Jetstar 762, line up, runway 16 right. Line up, runway 16 right, Jetstar 762.
Okay, auto brakes coming off.
The brakes are off. 80.
Air Canada 2033, take the high speed out from 4, ground 1265, good day.
265, Air Canada 2033, good day. Nice job.
Thank you.
Oracle, 1 hour, Charlotte.
So we exit the runway at about 25 knots on the high speed.
Air China 173, tower, apologies,
At ground and then the after landing, please manage and just the taxi light.
Ground, Air Canada 2033, heavy on Alpha 4 for Bay 9.
Air Canada 2033, good morning. On Alpha, cross runway 25, taxi to Bay 9.
Alpha cross 25 to Bay 9, Air Canada 2033.
Okay, I check we're cleared across 25 to Bay 9.
On Alpha, cross runway 25, international 2 to Bay 25.
So we're down to...
continue international 2, B25,
No train, no radar, off, there, 7, standby, APU to go.
Thank you. No, that's pretty close. He said touchdown at 42, and we touched down at 41.
Yeah, not bad at all. Normal lighting. View. Although.
Well, there's 9 there, right?
Yes, yeah.
Okay.
Yeah.
I'm going to wait
Yeah.
maybe till he parks before we go in. Does he care if we go in this way?
Good morning, I
guess we can go in either way, huh?
Channel 173, good morning.
Okay. All right. There's Bay 9. It looks like there's a crew waiting for us. And it's saying 777 on the board.
Yep. It's a good sign. There's nothing on the right side. It's all good.
Thank you, sir. Clear on the left also. All right. It's picked us up and it's guiding us in. Right now we're watching that board, and it starts count down our distance. When it tells me to stop, we stop.
Alpha cross runway 25 and line to Golf. Frankfurt Mark. 05 Alpha 116 right, contact 60.
All right, APU is running.
Thank you. Brakes are set. I'm gonna leave the seatbelt sign on because they got to remain seated for the spray.
Yes, for the spray, yeah.
Okay.
I bet.
Sitting ground just 38 by 33.
Morning, cockpit.
38.
Good morning, sir. Communications are okay. Brakes are set. The engines are shut down.
Thank you, and chocks are in.
Thank you.